Let's look at a completing the square example that does not have the constant on the other side and does not have a leading coefficient of 1. Okay, so right here in the middle, you can see this quadratic equation. The constant is minus 15, and it's over here with the variable terms. So we want to get rid of it on the left. We want it to be on the right. And what we're going to do is instead of a minus 15, we're going to do plus 15 on both sides. Okay, both sides of the equal sign. Negative 15 plus 15 is 0. So now I have 3x squared plus 12x equals 0 plus 15 is 15. Okay. Constant is now to the other side. Now, the leading coefficient is not 1. You can see here that it is 3. So we're going to divide all of our terms by 3. And the reason we do that is because 3 over 3 is now 1. And sometimes when you do this, you'll end up with a fraction here or a fraction here, and that's fine. In this case, this is nice. We just get x squared plus 4x equals 5. No fractions. And now we're going to do our other steps to complete the square. We want to make this left side a perfect square, binomial. So we're going to add the special number. This number that we add is going to make that a perfect square binomial. And to do that, we want to take half of the middle coefficient and square it. Now the middle coefficient is 4. Half of 4 is 2. And 2 squared is 4. And if we add 4 to the left, we have to add 4 to the right. Now the left side of this equation is now, if you factor it, you'll get the same thing twice. You will get x plus 2 times x plus 2. And I'm going to write that as x plus 2 squared. The right-hand side, 5 plus 4, is 9. Okay, now we're going to use the square root property. Okay, so you can look that up if you're not sure what it is. But what it is that we're going to take the square root of both sides, plus or minus, and then we have the equation down here. We have x plus 2 equals plus or minus square root of 9. Now, we know the square root of 9, don't we? That's 3. So x plus 2 equals plus or minus 3. Let's solve for x by getting our grumpy x by itself. I will subtract 3 from both sides of the equal sign. And now let me move this up here. I'm going to have, oops, I don't want to subtract 3. Look at this. That subtracting 3 wouldn't give my grumpy x by itself. I want to subtract 2 from both sides. All right, I'll leave that in there because if I make a mistake, you may make the same mistake. Now you know why. On the left-hand side, I will have just x because 2 minus 2 is 0. And on the right-hand side, I have negative 2 plus or minus 3. Negative 2 plus or minus 3. Okay, now you don't want to leave your answer like this. This is two numbers. This is negative 2 plus 3 and negative 2 minus 3. And we know that negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. So in this case, we get two integer answers, which means that this could have been factored all along. But it goes to show you that you can use completing the square even with something that does factor. We usually complete the square with a quadratic equation where our polynomial doesn't factor, because factoring is going to be a little quicker. But even if it does, and you didn't see it, that's fine. We still get our answers.